Hey guys, welcome back to the channel. Today we are going to solve a GFG problem, which is the problem of the day. Fixing two swapped nodes of a BST. Okay, it is considered as a hard problem, but I consider it as easy. So what's the problem telling us? Let's see. Two of the nodes of a binary search tree BST are swapped, fix or correct the BST by swapping them back. Do not change the structure of the tree. We are told that two of the nodes are incorrect in the binary search tree. We know that in binary search tree, the tree is arranged such that the left subchild is smaller than the root and the right subchild is larger than the root. Okay. Note, it is guaranteed that the given input will form BST except for the two nodes that will be wrong. Okay. The all other parts of the tree would be true, but only for two incorrect part we have to correct it. Okay. So let's see the example. Here we are given a tree 10, 5, 8, 2, 10. So we see that the incorrect part is 20 because 20 is larger than 8, but it is lying in the left subtree, which is wrong. So we have to replace 20 and 8. Okay. After replacing it becomes 10, 5, 20, 2, then 8. Okay. So this is the correct way to arrange the binary search tree as we know. So in the second example, it is given 11, 3, 17, 4, 10. So what's wrong here? We see that when we do an in-order traversal here, this will look like 3, 4, 11, 17 and then 10. But in binary search tree, we know that after traversing, the result comes out to be in a sorted way. So we have to replace this 10 with the 11. Okay, then we will get a correct output. So after swapping 11 and 10, we were going to get a correct output. So let's see. Ah, we have given an expected time complexity of O of number of nodes and expected auxiliary space of O of log n. What's the first approach coming to us? We can do a in-order traversal here. After doing the in-order traversal, we would get all the values of the nodes in a vector. Then we would simply sort that vector and put them back into the tree. So this time the tree would come out to be a sorted manner and which would be correct as the binary search tree states. So let's declare a vector here. Vector of int v. Okay, and we would declare in order. We would make a function of in order in which we would pass our root and vector. Okay, so we should go outside and declare a vector void in order of type uh, struct node star root comma. We have to send the vector here with its address because we are changing the vector answer if we get the root as null, then we would simply return from here. This is a void type function, so we could not return any value. We would simply break out from here. Then for in order traversal, first we go in the left subtree and after that we insert the values of the root in the answer and then we go to the right subtree. Okay, so we should do the same here. In order of root roots left and roots left, and we would pass the answer here and we would simply insert the answer, simply return the value of the uh, root in the answer, and again we would do the same for the right subtree, root right comma answer. Okay, so we have done the in order traversal here. let's make a function for the correction part. So let's make a function for the correction part. Void correction. In this we would pass the root in which we have to change the values, struct node root, and a vector of int ampersand. Let's make it as result. Okay, and a index. Okay, according to which we would insert our values. Again, we have to check here if root is null. Then we would do nothing and simply return from here. And we would first check for the left part. So correction root left subtree, and you pass a result here and index. Okay, and now at result index position we would simply we have to do the reverse part. Now we have to change the root value with the value present at that index of the vector. Okay, we are going to every time increment this value and go in the right subtree. Root right comma result and index, and here we are going to sort the vector which we got from the in-order traversal, v dot begin to v dot end. Okay, and now we would pass the value in index equals to 0, and we would call the correction part here for the root vector and index, and we would simply return from here the root. I hope this should run fine. Let's see. What is the error here? Root val answer. Oh, val is nothing. So it's data. P dot. I always do such silly mistakes every time. No member matching function for call. P dot begin. Oh. So we get the correct answer. Let's see if it runs. So yeah, it's submitted. So thank you for watching the video. I hope you understood the explanation. It was a hard problem, but I think it was. I hope you liked the video, and in case you did, please make sure to like, share, and subscribe, and share it with your friends. Till then, keep coding, keep practicing. Bye bye.